Hi folks, thanks for joining this session. I know you could have been at a whole lot of other sessions at this time of the day, and you could have had a whole lot of things that your life might have been calling you to do, so I'm really pleased that you've come to join me in this session. While you're here at the PASS Virtual Summit, get a good idea of the other things that PASS provides as well. You can find that at pass.org. There are PASS Pro memberships. I joined that a little while ago. I think it'll be very good value as time goes on. But as well, make sure you get involved in SQL Saturdays, the virtual groups, all the resources that PASS provides. At the end of the session, I'd also encourage you to complete the feedback. This really helps us to know what works for you and what doesn't work. And I know when you get to the end of the session, you might be very keen to run off to the next one, but please just take a few moments and complete the feedback for us. And for those that don't know me, I'm Greg Lowe. I'm the founder and principal mentor at a boutique consultancy in Australia called SQL Down Under. I'm a long-term data platform MVP. In fact, I'm a previous board member on PASS, and this is where I will have come to know many of you over the years. I'm part of the Microsoft Regional Director Program, which I often describe as just getting me into a whole lot of very interesting mailing lists inside Microsoft. I do writing, I produce tools, and a whole lot of other things. The main thing is I see myself as a lifetime learner, and I think you should be too. In this session, I want to talk about transformation versus migration, first up, and really what I'm getting at with that. And then if I convince you that you really should be making a transformation in your projects rather than a migration, what I'm then going to do is go through 10 areas in which I want you to rate your projects so you can sort of work out where you stand on the scale of just migrating across to transforming. So we'll start with the situation that I see all the time. I work in a lot of large financial organizations, typically things like superannuation companies, which in other countries you might call those retirement fund companies, those sort of things. Sometimes banks, many large organizations like that, but I also work with independent software vendors and software houses and developers. But one of the things I see all the time in large organizations at the moment is that they seem to be turning over their CIOs and CTOs. So the people that have been there for many years looking after systems, and in many cases doing what they consider a pretty good job, mostly with on-premises systems, those people are retiring or moving on to other jobs, and it's often well before they had intended to do that. And what's happening instead is that new CIOs or CTOs are then appearing in the company. Now, these people, whenever I talk to them, they talk about wanting to make a cloud transformation. But what I see nearly all the time is that they implement a cloud migration instead. All they're doing is picking things up, moving them into the cloud, and the problem is they're not transforming anything. Now, if you look at how this happens, in many cases, all they're doing is they're moving virtual machines to the cloud. And so it's a really common thing to do. On premises, they might have had a whole lot of virtual machines, and they presume I need exactly the same thing in the cloud. The only difference is I'm going to free myself from the hardware I had before. Now look, there can be benefits to that. A lot of people have hardware that's well out of support. Maybe it's not particularly reliable in many ways. It's hard to change when they need to adapt to different things. And so the idea of being able to just remove all that and get across to hardware resources in the cloud that you can make good use of and you don't have to worry about, that appeals to a lot of people. And when CIOs and CTOs talk to boards of these companies, the boards love hearing this, because the other way they see it is they see it as moving on from a whole lot of capital intensive purchases across to operational expenses, and they know that then they can scale better. So if the demands of the business get bigger, they can just scale up. If the demands of the business get smaller though, they can back off as well. Now, some of the cloud vendors have done a great job of this. I go into organizations, and one cloud vendor in particular will have often already sold an enormous number of virtual machine hours and things straight into the organization. And the problem with that is that whenever we're looking at doing a new project, the answer always has to be that it's going to be on one of the virtual machines that's provided by that vendor. And they're missing, in most cases, the real benefits of going to the cloud. You don't want to be, as I said, just picking up VMs and moving them into the cloud. The other people that this is not great for, though, are the cloud vendors themselves, because there aren't all that many of them, and if the only thing they're really competing on are things like the price of VMs, that's a race to the bottom for the cloud vendors, and it's not actually a great story for them either. So when these migrations are started, what's the promises that I hear? Well, first up, I hear that this is going to be a quick lift and shift. I'm going to take on-premises equipment, I'm going to move it to the cloud. It's also going to be minimally disruptive to the end users. So this should just pick up and work because we're doing the same thing. We're not changing anything too much. Very often, though, they talk about doing a phased approach. So the idea is that, well, instead of trying to make changes as we move to the cloud, what we'll do is we'll pick our equipment up, we'll migrate across to a whole series of VMs in the cloud, and then once we get to the cloud, we'll go on and then tackle the transformation. But what's the reality of the outcome? And so what ends up happening is they end up taking their existing problems and they take them with them to the cloud. It's still highly disruptive to the end users, and in fact, the end users end up quite unimpressed. But the other really nasty aspect of this is that in so many situations, they end up with higher costs than what they were expecting, and the budget that they were looking at using for this migration and transformation has all been consumed by the migration, and there are no funds left to do the transformation. Worse, the boards have already got to a point where they don't want to invest anymore because they feel like they've already spent way more than what they had in mind. So this leads to a really poor outcome for everyone involved, really, except maybe the cloud vendor. A bigger issue is that it doesn't tackle a lot of the basic problems that are occurring. And so there are changes that are occurring in a lot of businesses today that are not met when we do this sort of migration. Organizations are very used to providing scale at an employee level. And so this means they provide systems that are enough for their employees to use. But increasingly, the same organizations are needing to move to customer scale. And this is where the customers are interacting directly with their systems. Now, you can do some scaling on VMs. I mean, I can take a VM, I can change it to a different size VM. But it's not going to fix the core problem, where what I really want is some sort of auto-scaling. I often see a curve drawn like this, where they show the demand for IT resources in an organization. And of course, it fluctuates all the time, all year long. You have peaks, you have troughs, and that's just life. But if you ask the IT people what level of resources they want, what they ask for is something that's going to cover the entire situation. But of course, that's not what happens. What ends up happening is they're allocated resources that are somewhere less than that. So the idea is they're given resources that should be enough most of the time, but then there are going to be periods where they're not good enough. And so doing these sorts of things with fixed size VMs, and it was even worse on premises, just leads you to a situation where you really can't cope properly. Whereas if you compare that to a scenario where if I have a stateless, say, web application, and I don't have to have it on one particular machine, but I have it structured so that if the system is busier than a certain percentage over a period of time, it just spins up another web app or another and another. And if it gets quieter, it spins it back down again. You are in a much better situation than if you have a scenario where you're spinning up virtual machines and running web servers on top of that. So the thing is, you really need to be moving more and more to sort of platform services that provide this sort of flexibility. So now what I'd like you to do is go through these 10 areas with me and think about the projects that you're currently working with and rate yourself as to how you fit on a scale. Let's imagine 1 to 10, where we've got these 10 items that I want you to assess things on. Now, the first of these areas is identity. This is critical. When you're making a move to the cloud, the main thing you must get right really early on is identity. I've seen too many migrations where people don't deal with identity appropriately, and they end up with an even bigger mess than what they may have had on premises. Now, on premises, people already have a lot of problems. I mean, I was doing work today for a client, and I think I have to log on something like 8 times by the time I get to the systems I need to use, and so on. This sort of thing is ridiculous, and they have different levels where I've got different passwords at each point and so on, because they've got different renewal or refresh of the passwords and so on. It gets worse when you start adding cloud services. So if you have a cloud service you add, you don't want people to have yet another password and yet another identity to go dealing with that. You need to sort this out really early on. So in each of these areas, I want you to think about, what does dated thinking look like, as opposed to what does cloud native thinking look like. So the first of these is if you're still very Active Directory based, where it's a standard domain that you may have had on premises. And so this is a really common starting point for a lot of organizations. You'll have Active Directory in place, but the question is, where do you move from there? Now, you could be picking that up and just taking that to the cloud. You could move your domain controllers to the cloud and you could do the same things, but that's not cloud native thinking. That's still quite dated thinking. If you have external people who come in to do work for you, if you're allocating them addresses and identities within your organization, that's actually still dated thinking. So imagine I go working for superannuation company A. It's really common they'll give me an email address where I'll be greg.lowe@superannuationcompanya.com. And when I do work for superannuation company B, they'll give me a g.lowe@superannuationcompanyb.com, and so on. So I'll have separate identities in every single one of these organizations. This is not cloud native thinking. I also commonly see scenarios where people build applications where they store usernames for users and they'll store passwords in databases. Now, usually they're clever enough not to store a password directly, although that's not always the case. But even if you're storing usernames and hashed passwords there, I look at that now and say you shouldn't be doing this anymore. If you look at the problems that companies like Microsoft and Google and Yahoo and all these people have with identity, they have thousands of engineers working on this sort of thing, and they still run into problems. So if you find yourself building your own identity system, you really should be reminding yourself that this is not the cleverest thing you're ever going to do. And worse, what I see all the time is people not even using appropriate hashing algorithms. I was doing work for a company just recently where they had decided to write their own encryption algorithm for doing the hashing of the passwords. And in fact, they hadn't hashed them. They had just done a simple obfuscation of the passwords, and literally it took about 10 minutes to be able to work out every password on the system. That's not sensible, and you must not do that as time goes on. The other thing that's a telltale sign is if the IT people in your organization are spending all their time sorting out identity issues. I go into government departments, and what I see is half the department is dealing with, so-and-so can't log on. They can't, something's happened to their access. They need their password reset, things like that. If your life is full of that sort of thing in your system or help desks or whatever, then again, you need to move beyond that. Finally, I see organizations who need to expose information on their site to other companies, and they go off and build custom APIs to do that, and then they build their own authentication schemes for those APIs yet again. And so once again, this is not what you want to be doing. Going forward, you want to start thinking about Azure Active Directory as the core directory for your organization, not just some add-on one. So for most organizations today, the Active Directory they have on premises is their main directory. But as time goes on, the one that they have in the cloud is going to become the most important directory, not the one that's currently on premises. And this is because it's going to be used for a whole lot more things than what you're currently using the current Active Directory for now. You can set up hybrid AD, and that's straightforward at the moment. So you can have an Azure Active Directory for your organization, you can have your on-premises directory, and you can use AD Connect to connect the two together and synchronize them. And that allows your staff to be able to use their same usernames and passwords when they're using the cloud-based applications like Office 365 and Power BI and so on, as they use on premises. Importantly, what that can also do is make a big difference to the overhead you have, because you suddenly enable things like cloud-based password reset that people can do by themselves and so on. It looks great because you can do branding on the Active Directory, but more importantly, you can use the same directory to connect to a whole lot of other applications. So if you want to use Dropbox for your data, or you want to use Zendesk for your help desk, and so on and so on, there are thousands of applications today that can use that exact same Azure Active Directory identity as the identity for that. So you don't want a scenario that when you move to the cloud, you have separate identities for all these different cloud services you use, because as time goes on, you'll probably end up using quite a few of them. It's also important, wherever possible, to try and use what are called managed service identities. So if I have something like Azure Data Factory, and I need to use that to manipulate data, and I need it to connect to SQL Server. Now, I can go through and set up SQL Server authentication and use a username and password and connect it up that way. You could do that, but again, that's not a great option. Wherever there are managed service identities, the service itself has an identity, and you're able to assign that to a role or a group that is then assigned to a role inside SQL Server. So that way you can give direct access without having to manage usernames and passwords on an ongoing basis. A really big aspect of Azure Active Directory is it also has 3 styles or modes in which it runs. So it has the core directory, and this is normally what you'd use for all your users in the organization. It then has a concept of B2B. So this is business to business. So the idea there is that if I go to do work as greg@sqldownunder.com, and I go to do work for superannuation company A.com, they can just add me to their directory. They can add me to groups, they can give me permissions and things without the need to create another identity. Importantly, if they later decide to then move me on, it's going to be that same identity that they just disable, or in fact, if there are multiple people from my company who are working there, they can just disconnect the lot of us and avoid issues where people end up with credentials for longer periods than they should. But it also means that I don't have to have a whole lot of different passwords for all these different organizations, because that's not safe. The more passwords that people have to have and the more complicated you make them, the less secure your systems get. So you don't want to be doing this. Now, you still can have additional requirements. Like I might decide not to use multi-factor authentication. We do use that, but I might decide not to. But one of my clients might decide that that is required. That client can still require me to do it, even though I don't do it normally with my own identity. So that sort of thing can be controlled. And finally, there's a third mode that Azure Active Directory runs in, which is business to consumer, B2C. And this allows you to have external users that you need to manage in some way. So for applications where you would normally have your own usernames and databases, maybe members of a superannuation fund, and have them stored in your database, you don't do that anymore. What you do is create B2C users, let Azure manage that, and you just use the identity that comes back from that as an identity that's in your database. But you don't get involved in your applications in authenticating things and having to manage usernames and passwords. Importantly as well, the cloud-based password resets and so on are going to relieve a lot of your activity that you'd otherwise have with endlessly resetting these values for members of a fund or something like that. So cloud-based password reset can be a really big deal. The next aspect I want to talk about is databases. And of course, this is something dear to all of us here at these sessions. Dated thinking in this area is where you need to use SQL Server VMs. So if I'm picking up SQL Server applications, I'm taking an on-premises SQL Server and I'm moving it to the cloud, and all I'm doing is putting it in a SQL Server VM, I'm not really getting the main benefit out of things. If you have a need to use managed instances even in the cloud, I still think you're not really quite at the level of getting the true benefit. Now, managed instances are a wonderful thing. They're great because most of the basic care and feeding and management is done for you by Microsoft, but it still has way more admin and way more configuration than I really would like to see. And so what you also see people do is they're trying to aim for database agnostic outcomes. Now, this sounds like a great idea. So if I write an application, maybe I want to build the application so that it doesn't matter what sort of database backend I have. So maybe today I'm going to deploy against SQL Server. Other times I'm going to deploy against Oracle. I might deploy against Postgres and so on. You can build applications that will do that. And look, sometimes you have to. Maybe you're a software house and your customers are insisting on you deploying on those different platforms. But if you can avoid that, I would suggest you avoid it. What I see all the time are people who build applications and they say it's going to run on all these different platforms. And what ends up happening is it ends up running incredibly poorly on each platform. It doesn't actually run well on any platform at all. They've made lots of compromises inside the code. Often the performance is really, really poor. And you know the worst part is that almost every time I've seen this, they never end up changing to a different database anyway. So they've gone through all that pain, they've gone through lousy code, they've gone through the performance issues for a scenario that doesn't happen. Now, cloud native thinking in terms of databases is that we use something like Azure SQL Database. I'm a big fan of the standard platform service. So Azure SQL Database. I want to manage a database in terms of how big is the database, how fast does it have to be, maybe where is it stored, is there a replica, and if so, is the replica readable, and so on. These are the types of words I want to use. I don't want to use words like, how do I configure an availability group? What sort of network connections and things do I need between the servers and so on? How do I work all of that sort of layers of stuff out? Importantly, organizations don't want to know about this stuff. I don't want to do patching. I don't want to do operating system hardware reconfiguration, patching and so on. I just don't want to do that. Look, if I look at our own situation, I used to run SQL Server in various places and hosted and so on and in various spots for our own internal applications. Since the day I moved our applications to Azure SQL Database, I have never thought about those databases again. It's really been that much of a difference. Now, organizations want to think that way. Developers really want to think that way. All you want is you want a T-SQL endpoint that you can send commands to, and you want to manage the database declaratively, not procedurally. So you don't want to say how all this stuff works. What you really want to do is just specify what you want and how it should work. This is the key difference in here. The other big advantage of this is you no longer need to have a whole lot of people who know the intricate details of how to configure that. So if you need to maintain everything from availability groups through various clustering arrangements and so on, you need people on staff who really know what they're doing. Now, alternately, you can offload that to Microsoft, and I can tell you from an organizational point of view, you may have made them have an interest in operating system patching and security patches and things like that, but I can assure you the organization doesn't want to know. A third area I'd like you to consider is if you're involved with multiple databases. Now, this doesn't apply to everyone, but there's an awful lot of people that this does apply to. Now, if you need to manage multiple databases, perhaps you're building an application and you have a whole lot of clients that need to connect to the database. So a traditional non-cloud-based thinking is that we're going to be focused on having a single large multi-tenant database that has all of the customers' details in it. So customer A, customer B, customer C, they're all going to be there in that database. If I fill it up or it's too slow, maybe I'm going to add another database. That's the traditional thinking. And all of the things that you focus on are the restrictions, like licensing, like how does the storage work, and so on. And the big thing that happens here, though, too, is companies often don't understand the risk involved. You can have a much better situation if you start thinking about using multiple databases in many cases. Now, this is not for everyone, but it's an area that you should consider. If I'm building a software as a service application, there's a lot of reasons why I like to have a separate database per client. But imagine if you had 5,000 clients, that's not something you'd want to do on your normal database servers. If you've ever seen SQL Server run with thousands of databases on a server, I can tell you the tooling and so on, it's not a pretty sight. I mean, it works, but if you haven't ever tried that in something like Management Studio, it's quite an experience. And so usually doing that on a single server, not a great idea. And the other thing, though, is that it avoids a whole lot of basic problems if you have separate databases. Once you're in Azure, you're going to have separate resources for each of those databases. So you're not going to have the noisy neighbor problems. You don't have the issue where one database user is causing major problems for the other database users. It also helps you avoid things like if I have a noisy neighbor and I need to move a database user to another machine or another database, I've got to write a whole lot of tricky code to pick that customer's details up and all of their data and move it across to the other database. There's complexity there in terms of getting it right. But one of the big ones for me is the risk. And the deal here is that if you have a single database where you have all your clients' information from all the different clients in a single database, you've got to understand that you're only one where clause or one predicate away from sharing somebody's data with somebody else. Now, that may not matter to you, but I can assure you for a lot of companies it does. And so I work with a range of companies. If you imagine your managing director and she's there talking to a customer and you have just exposed their data to someone else, imagine what that discussion would go like. Now, for some customers I work with, that would be deeply embarrassing. For other customers I work with, that would be terminal for the organization. And so there's a risk level there that you need to assess. Now, part of the problem with this, though, is that when you're buying multiple databases or big databases, it is lower cost to go and get bigger databases and push a whole lot of people into it. But you've really got to think long and hard about what that risk profile looks like. You can also, when you go to a more cloudy nature of having separate databases there, you get other benefits. So for example, if you have one client who wants a really low spec database, you can do that. And you could have different clients who then need a very high performing one. Or maybe they want a replica in another place and so on. Those sort of things all become issues and options for you to consider as well. So just think about it as a way of working. You also have individual scale, like I said, but also recovery options. If you have one customer who said, look, I messed it up, I'd like to restore to 2 days ago, what do you do when it's all in one large database? So think long and hard how much easier it would be if they're sitting in different databases. This is a sort of a cloudy way of going. Now, in Azure SQL Database, they give you options for this around elastic pools. Now, that doesn't give you totally all that flexibility, but if the price is the biggest thing you're worried about, it's worth a look as well. Storage is another area I'd really like to call out. Now, dated thinking, are you in an organization where you're just endlessly running out of space in storage? I can tell you, I'm in a lot of those organizations on a regular basis. I ask for a certain amount of space, so I have headroom for a database, and suddenly I find I've got, well, not quite that much. And the number of times we have things running out of space and so on, that's a problem that happens. Now, in many cases, that's because they've got some corporate SAN that has incredibly expensive storage, and they really can't afford to have too much there, so they're endlessly trying to work out how to limit the amount you get. Often they have very poor high availability options for the storage, and if you look at the recovery strategy, in a lot of cases, they're limited to just restoring from a backup. Now, if they do have tiered storage, that's normally only available as part of a SAN. And so maybe they have things where they have hot data and data that's warm or lukewarm, and they might have cold data. That might be available, but it's still often really expensive. So being plagued with a lack of disk space is often very much in the dated thinking category. Now, if you look at what's available cloud-wise, you need to emphasize using cloud storage. So if I'm storing anything from documents to whatever I need, blobs of various types I need to store, cloud storage is unbelievably low cost. It also gives you options for tiered storage. So you have the ability to specify, is this really, really fast? Am I on premium SSDs? Am I on standard hard drives? Have I got hot storage? Is it readily available? Have I got cold storage? Maybe I have data in some type that I'm happy to wait for a while for it to become available. And the key thing though is it's virtually limitless. And so if you can work with that style of storage wherever you can in the organization for applications, for databases, for all sorts of things, that's a much more cloud native way of thinking. The fifth area we'll look at is loading and transformation. Now, a traditional thing on premises might be to use SQL Server integration services. Great tool, worked well for many, many years. It's been really good to use. But if what you're looking at doing is picking it up and moving it to the cloud, the bottom line is it's not a cloud-based application really. Now, you can pick up and move your integration services packages, but a hint that you're probably still a bit in dated thinking is if you're looking to run those same packages in the cloud. Now, you might need to for a period of time, but wherever you can, I try and avoid that. So a telltale sign is if you're needing to install SQL Server VMs to run integration services, or you're using things that force you to use managed instances instead of platform databases. Another option is you can pick up integration services and put that into Azure Data Factory and run your existing packages. Look, it's amazing that they have made that work. It's just, again, not my favorite thing to do that. And if you look at most of your scheduling and it's still based on using SQL Server Agent, then this is also kind of a dated thinking. If we look at the alternatives, most of the time we try and build things native now to run in Azure Data Factory. So rather than doing a lift and shift, wherever we can, we try and pick it up and move that there. Sometimes we'll make use of Azure Functions. These are wonderful. They're basically a function that runs serverless, can fire up and run a piece of code on a trigger. That could be on a timed basis. It could be on an event when something happens. You can do similar stuff with Azure Automation. But if I look at the typical way we trigger things nowadays, it tends to be with Azure Data Factory and its triggers, or alternately, there are cloud-based enterprise schedulers that some organizations use, and we look to integrate with those. The sixth area to focus on is how you do investment in equipment and licensing. So the dated thinking is that you buy a whole lot of servers. You run out, you place orders, you get machines, you drop them on the floor. You could also be buying traditional software licenses. So we might be periodically buying new licenses for SQL Server. All of these tend to be focused on capital expenditure. And that's the traditional telltale sign of a sort of dated thinking. But the problem with this is that it really commonly ends up having out-of-date software and hardware as well on sites that I work on. And so even today, I was again doing work with another client, and we're talking about Windows Server 2012. Some sites I've done work on lately were on Windows Server 2008. Now, there really today is no reason to be doing that. The reason that this happens, though, is they've bought a piece of equipment, they've tried to get as many years out of it as they can, and that's the operating system and thing they bought with it as well. And then when it got to the period where it's maybe out of life or out of support, all they're doing is going, well, can we just run that a bit longer again? And they keep stretching it out. The worst thing with that is that there's so many things they could be taking advantage of in the later products, and the company's not able to do that. Having a real focus on buying equipment is a real limiting factor to an organization. I'll give another example. I was doing work for a company who's a large software house, and they have a real focus on always buying equipment rather than cloud-based work. And I needed to do some testing on availability groups. Now, if I had have been able to do that in Azure, I could have started the work straight away. Instead, they always told me that it was cheaper for them to implement their own systems. Now, from the point where I asked for the servers, it took nearly 4 weeks for them to get a quote. Once they had the quote, it took 6 weeks for the equipment to then arrive. So that was 10 weeks already gone. And then when the equipment finally arrived, they told me they couldn't install it. And the reason was they needed to go in a rack, and they couldn't take a power outage on that rack, which they had to do, for another 4 weeks. So this ended up being a 14-week thing just to get a couple of servers to do work. By comparison, if I'd been able to do that in Azure, I could have spun the servers up later that same day, done the testing the following day, and spun them all down again. The whole thing about doing capital-based equipment purchases, really, it's time to get beyond that. And cloud-native thinking, by comparison, is that we do platform-style licensing. So if I buy access to an Azure SQL database, for example, or Azure Data Factory, or any of these sort of tools, I buy access to a platform service, it already comes with the licensing required. From the minute I buy it, I'm using the latest version of it all the time, and if I don't need it anymore, I can get rid of it. Importantly, I can scale it up and down to the level that I need. As a simple example, one of the databases we use for some of our training courses, we have a database that sits there all the time as a basic, as really cheap, like $5 odd a month. When we need to use it for a class, we push that up to an S3 in the morning, and so it goes right up to 200 DTUs rather than 5, which is where it started performance-wise. We run that for the day, and then we spin it back down to a basic again. In the end, that costs a few dollars to do that. But the people who use it during the day get an amazing outcome. Now, this is the same with so many of these things. If I have Azure analysis services, maybe I can just move it to a different scale just before I need to do heavy operations. Perhaps I have end-of-month processing that needs to be done on a database. I had one just last week where I needed to rearrange the contents of a database. There's a world of goodness in being able to just suddenly push it up to be 200 or 400 times faster than it was, do the work, and then just spin it back down to where it normally lives. This is a different way to work with equipment, but once you start experiencing that, you will never want to go back. This all becomes operational expense focused as well, and the beauty of this is you're not tied into long-term contracts and so on with high amounts. This is also a problem though if all you do is pick up and move VMs, because most of the VMs you're going to find the way to buy them, of course, is to make a reservation on the VMs and commit to long-term use of a particular piece of resource. Now, you can do upgrades as long as it goes up, often within the VMs and so on, but that is not the same flexibility as if you're able to just spin things up and down as required. I'd encourage you to really, really look at that as an option wherever you can. Another option to consider are serverless options. Now, this is where we have various functions in Azure where you don't pay or configure for a server. It just uses the data and you pay for the period where it's used. We have those options in SQL Server now. When you're using the data, it's more expensive than a standard platform service, but you don't pay for it when you're not using it. And this is really important. So if you have things that are only periodically used, you may be better off with a serverless option. Many of the platform services also give you the ability to pause. So for example, if I look at the price of Azure analysis services and I look at what that is per month, and I might go, wow, that looks like a lot of money if I go up to a higher tier of it. But if I only use it for 8 or 10 hours a day, there's absolutely nothing stopping me getting that server and then pausing it at the end of the working day and then starting it up again at the beginning of the next day. Now that might cut my bill for using that, well under half the original bill. You need to be in an arrangement where you have this flexibility. The more you're committed to periodic buying cycles with licenses and hardware and so on, the less flexible it is for the organization. And this is where you get stuck on old equipment. Another interesting aspect of that too, just to consider, is that it's also harder to keep staff. I mean, if you have people, how exciting is it? For example, at the place I was talking about that had Windows Server 2008, how excited is it, do you think those people are to go to work every day and work with infrastructure and services that are that old? An area where you may have significant challenge is with applications. And so the dated thinking here, if you have Windows Forms applications that all you're doing is picking them up and moving them to the cloud, many of those are very chatty applications. It's incredibly common for really chatty WinForm apps. I saw one just a little while ago where from the minute you started the application till the first screen came up, it did 90,000 remote procedure calls, 90,000 calls to the database. Now, it's a testament to SQL Server on-premises that application started up in about 30 seconds. But the minute you add a bit of latency into that call, as you often have in cloud-based applications, that can stretch out to a very long period of time. You can't afford applications to be that chatty. There's one company I did work for a little while back who write software for superannuation companies. I sat and traced a logon to their application one day, and from the minute a user logged on to when the first of the main screens of the application came up, by that stage they had made 400 database calls. You just can't do that and expect to get a good outcome. In fact, I often tell people when I'm talking about SQL Server, I get asked how to scale SQL Server. And let me assure you, the best way to scale SQL Server is to stop talking to it, right? So if you stop endlessly chatting to it, you'll actually be in a much better position to scale it. Another telltale sign of dated apps are where they're not tolerant to any sort of failure. So if you drop a connection and then the application breaks, that's not a good sign, right? I go into organizations all the time where the organization has spent a fortune on highly available equipment, yet the minute it fails over, like it's designed to do, every app in the building breaks. And so you've got to say, look, did the developers do their job? No. Could you build an application that can deal with the fact that the server disappears for 20 or 30 seconds? Of course you can. But it's not going to happen by accident if you just open a connection and depend upon the fact and hope for the best that it's just going to stay there the whole time. Another telltale sign is if you have web applications that require sticky sessions. So if they're holding state in the web server rather than in the database or in a memory or session state of some type, then the problem is that when a user comes back to hit the web application, they then have to get routed to the same web server. And so they call this sticky sessions. And so if you have applications that require sticky session support, then these are not really sort of cloud thinking type applications. And it really limits your ability to scale properly. Where stateless applications and app servers are what you're aiming for in the cloud. And ideally, you want to get to a situation where these can be auto-scaled. And so both up and down, or in and out. So more servers, less servers, or faster or slower, these sort of options. But you should be able to do that dynamically while the app's actually being used. And the applications should be highly fault tolerant. So if things drop out in terms of their connection to a database or something, and then comes back a little bit later, you need the applications to be at a state where they can just continue on. The eighth area is to talk about testing. Now, I've been in lots of organizations who do this very differently to each other. A telltale sign of dated thinking is dedicated test hardware. Lots of decisions that are taken based upon the cost of VMs, a high degree of manual testing going on, and often in those places, you'll find a queue for those testing resources. I've been in places where there are a couple of very large machines that are used for testing. There's a queue of people who are waiting for their work to be tested. And in many cases, they can't move on until that testing's done. Cloud native thinking, by comparison, is that you spin up and down test machines or resources as they're required. So again, instead of buying a whole lot of test machines, when we need to do testing, we spin up resources, we do the testing, we shut it down again. You need to have a real focus on automated testing. And the other thing this does is it avoids the big queues. Because once you're paying per hour for resources, it doesn't matter if you use 1,000 machines for 3 hours or whether you use 3 machines for 1,000 hours. In the end, the cost is the same. So you don't have to have these sort of queues of people waiting to do testing. This is a much more dynamic environment for your developers. Bill Baker has an analogy where he says you need to stop thinking about pets when you're talking about servers and start having an analogy where you think about cattle. So the idea is that when you have something that's a pet, you have a server that everyone gets to know the server. And the server, we care and feed it, we look after it, we name it, and so on. And there's an endless thing to try and keep it alive all the time. The comparison is to have cattle where really what we're saying is, let's just spin them up as required. All of the infrastructure is deployed as code, and we just remove them again when they're not needed. Area number 9 is project management. How do you manage projects and what systems do you use for that? Again, dated is where we're not really making good use of source control, particularly in database applications. That's really common, but also for infrastructure. If you look at how so many people spin up servers today, they have a list of requirements, they get some person to spin up the required VM, step through the steps, if they have spelled them out, to go through and configure the machine appropriately. Nowadays, you should never be doing this. Now, you could also be using something like PowerShell, and maybe I could go off and I can define in PowerShell a whole lot of steps saying do this, do this, do this as I'm configuring things. But again, the problem with that is that it is a big step over, the idea of a person doing it. But the problem with that is you're still doing it procedurally. And it's really hard to specify what it is you're trying to achieve when all you're doing is specifying how to do it. So if you haven't looked at it, you need to start thinking about things like desired state configuration management, where what you're saying is this is what I want the machine to look like, and then you're letting the system put it into that state. And that's been possible now for a number of years. But really importantly, you need to make sure that you use infrastructure as code, and the infrastructure should be defined in code, and there should be no surprises. Most people who are still in dated thinking have these manual, error-prone build and deployment cycles. And because every time they do a deployment, they have a problem, they get further and further between deployments because it's a big deal. And of course, the longer that they do this, the bigger the deal it is, the more painful it is, the less interested they are in doing it again the next time. And so this is a cycle you don't want to be part of. So cloud native thinking, in the case of databases, is to be using database projects. If you're using analysis services, again, we use tabular database projects, and so on. You build the things in projects and you deploy from there. Importantly, you consider continuous integration and continuous deployment. That becomes an important thing where it can be automated, particularly can help with things like testing. So perhaps when you put new code and commit it into a repository, that triggers off a build of the code. The build then maybe gets picked up and deployed to a test environment, and then it's already there where it then runs a bunch of automated tests before anything else happens. And you can automate all of this nowadays. It doesn't have to be manual. And what it leads to, though, is something where you're not scared of doing deployments. It was interesting, I saw Scott Hanselman the other day talking about how he used to build his blog. And he used to do a deployment every so often, and it was a really big deal. And he was just totally bemused that the other day, after he changed it, he'd done 7 deployments that day. And so on. This is where you want to get to, is a point where you're not scared to be doing deployments. And the 10th and final area we look at is expanding your horizons. Dated thinking in this area is where all you're aiming for is to go from the on-premises system to the cloud one without really changing anything. You're aiming for like. You're not using any new services. And the downside of this, though, is that the users are going to go through a lot of pain, even though you hope they won't, but there'll be minimal benefits for them in the end. They're going to look at this later, and after they've been through all the pain and the disruption, they're going to go, what was that? What was that all about? In fact, what was in it for me? By comparison, cloud native thinking is we're going to use new services as well. So for example, it might be search or cognitive services, machine learning, and so on. Now, you might look at those and go, I don't use those. In fact, a superannuation company I was doing work for a while ago, if I had gone into them and said, what use could you make of cognitive services and describe what the services are, they would have told me they couldn't use them. But what's interesting is then you look at projects that we're able to do. So we're able to take, for example, all their phone calls from their call center. I can get the calls, I can push them into cognitive services, I can then have it go through and transcribe the calls for me. I can then take the calls that are being transcribed and I can do key phrase extraction, and so on. This becomes really interesting because a traditional company like this has to monitor what happens in their call centers, but they can only ever normally monitor 1 or 2 calls. But a big worry for them is that staff are not allowed to say things like, I recommend, or I think you should, and so on. And so if those words come out of the mouth of any of the staff, they need to know what was said after that. Now, imagine instead of sampling a handful of calls, I could go through every single call and have a machine go through and do that. And you'd say, is that of value to you? Of course it is. You'd get a completely different reaction from them. As another example, if I had something where I'm scraping social media and I'm pulling down everything that's being talked about the company, and I can, in one case, I had to go and do language detection because the company I was dealing with, there was a company in Brazil where there's a supermarket with the same name, and there was all this Portuguese stuff on social media with the same name and so on. These services are wickedly powerful, and if you're not doing something where you're offering something better to the users, they're going to sit at the end and really wonder what all that pain was about. You owe it to them to do something special for them. So in the end, how did you rate your organization? I hope it's not down in the 0s and 1s and 2s, and at least you're part of the way up the tree. It's really important that when you spend all this money and when you make this move, that you really offer something special to your end users, and that's going to require a transformation because that's where the real benefit lies. Look, I'd like to thank you all for being here in this session. Don't be strangers though, stay in touch. I've put details there of you can email me, you can grab free stuff from me. I have a whole lot of ebooks and podcast and SDU tools where I've got a whole lot of tools you can use in SQL Server. Put details on my blog there. If you want to learn from me, I have free and paid training. And just in general though, I know you could have been at a whole lot of other places instead of being here in this session. So I thank you for being there with this. And we'll end up in a session now where we can take some questions. But as I said, thank you, and please remember to fill in some feedback.